Hello, everyone. Welcome back to the third episode of the Retroverse podcast. We dive deep into the intersection of science fiction, gaming, and the real world science that can make it all possible. I'm your host, Retro, and today this episode will be a little bit different. Will be just be myself, and together we'll be setting a course for one of my favorite corners of the Star Citizen universe, the Stanton system. Now, this isn't just going to be your usual game updates deep dive podcast. We're going to go full science here. We're going to look at a few of the standard planets, Hurston, ArcCorp, and Crusader, and explore what they'll be like from a geological and planetary science perspective. We'll compare them to planets in our own solar system, talk about what's actually possible with what we know today, and ask the big question, could humans really live on worlds like these? So fire up your quantum engines, and let's begin. The Stanton system. One of humanity's crown jewels in Star Citizen. It's got four major planets, Hurston, ArcCorp, Microtech, and Crusader, all orbit around a yellow-white star not too different from our sun. But what makes Stanton unique isn't just the diversity. It's that each planet is privately owned. Imagine that. Entire worlds is corporate property. Hurston's owned by a weapons manufacturer, ArcCorp by a megacity conglomerate, and Crusader by an aerospace giant. But the fascinating part isn't just the lore. It's about how these planets themselves could function. You've got terrestrial planets like Hurston and ArcCorp, both resembling super-Earths, larger, denser worlds similar to our own, and then you've got Crusader, a massive gas giant where humans live up in the clouds. Scientifically speaking, that's a goldmine of planetary variety. Rock, metal, gas and atmosphere all on one system. So let's descend now. The first stop, the industrial scar of Stanton, Hurston. So when you land in Hurston in Star Citizen, it hits you immediately. That brown, smog-filled haze stretching to the horizon, the planet's been gutted by industry, and it shows. From a geological standpoint, Hurston is what scientists call a super-Earth. A rocky planet, maybe 1.5 times Earth's size, but a few times heavier. That means gravity there would be stronger, you would feel it every step, your body would be slightly heavier, your muscles will be working even harder just to move around. Even breathing would be difficult. But stronger gravity doesn't just pull hard on you, it pulls harder on the planet itself. Let me break that down. So when a planet's larger, its internal pressure and temperature rise. That means that the core stays hotter for longer, fueling geological activity, things like volcanoes and tectonic movement. So what actually causes these volcanoes to begin with? They're basically Earth's pressure valves. Beneath the crust, molten rock called magma builds up in its chambers, and when that pressure gets too much, it forces its way up through the cracks into the crust and erupts at the surface. Those cracks form along tectonic plates, giant slabs of rock that make up the outer shell of a planet. These plates float on a layer of softer molten rock beneath them, slowly drifting over millions of years. When plates collide, they form mountains or cause quakes. When these pull apart, the magma rises to fill the gap, forming a new crust. That constant recycling keeps a planet geologically alive. On a heavier planet like Hurston, that process could be amplified. More pressure means more internal heat, and that could even mean more frequent volcanic activity and stronger earthquakes. Now here's something cool. Heavier gravity means faster sediment settling. When wind or water carries dust and sand through the air, those particles fall faster in stronger gravity. Hurston's surface would form thick, compact layers of soil and rock much quicker than on Earth. Imagine shaking a snow globe. On Hurston, those flakes will drop faster. And there's even more. So the higher gravity could influence how ocean currents and river flows, making erosion more aggressive in some areas. Combine that with decades of strip mining and pollution, you've got yourself a planet that's not just alive, it's overworking itself. Living there, it's possible, but it'll be punishing. You'll be dealing with heavy gravity, toxic air, and unstable ground. Every day would be a challenge, but it would also be a test of human endurance. Hurston isn't just polluted, it's geologically alive. Nature and industry grind against each other beneath a yellow, oppressive sky. From Hurston's wastelands to ArcCorp, a total contrast. ArcCorp is a planet that's completely wrapped around in steel and concrete, a city world, a planet that never sleeps. In the lore, it's been fully developed, it's been terraformed, urbanized, and industrialized until the natural world is gone. From a planetary science perspective, that's fascinating because it shows what happens when a planet's geology is completely replaced by engineering. Covering an entire surface in buildings and metal changes how sunlight interacts with the planet. That's called albedo. Ice reflects light and asphalt absorbs it. ArcCorp will trap heat, pretty much a global urban heat island. Nights will stay warmer and days will become hotter. Then there's hydrology. On Earth, water filters through soil and rock, feeding rivers. On ArcCorp, every drop of water has to be managed artificially, through pipes, reservoirs, and pumps. Failure could trigger citywide floods. Even underground, the planet is alive. ArcCorp still has tectonic plates. They move, shift, and occasionally earthquake. Imagine a planetary scale earthquake shaking billions of tons of steel and concrete. Engineers would be constantly having to monitor and prevent this disaster. And climate engineering, on a citywide scale, mirrors in orbit, artificial clouds, and temperature control would all be essential. One misstep could throw the entire planet's weather out of balance. Living there would feel less like inhabiting a planet and more like living inside of one, an enormous breathing machine, a human city fused with planetary geology. Alright, let's go big. Crusader, the gas giant. In Star Citizen, these humans live in massive floating platforms high above the clouds. No ground, just sky, endlessly shifting, alive. In real science, Crusader would resemble Jupiter or Saturn in our own solar system. They are huge gas giants mostly made out of hydrogen and helium. These planets don't have a solid surface like Earth. If you try to land on one, you'll sink until the pressure on the inside would crush you. The scientists define a surface by pressure, not by rock, on these gas giants. At about 1 bar, the same as about Earth's sea level, the surface is breathable. Below that, the pressure skyrockets. This hydrogen becomes metallic and generating massive magnetic fields. Floating habitats would need to hover in a layer where temperature, pressure, and density is stable enough where it's about the sweet spot. NASA has even studied this concept for Venus, since the upper layers of the Venus atmosphere are relatively mild and could be suitable for human habitation. But the challenges would be immense. Gas giants have violent storms, supersonic winds, and massive lightning. For example, Jupiter's Great Red Spot has been raging for centuries, and it would be very difficult. Floating cities would need to have active stabilization, radiation shielding, and constant adjustments to stay afloat. Crusader's clouds also contain ammonia, methane, and water, giving the skies ever-shifting greens, blues, and oranges. Jet streams tear across the atmosphere in 100 kilometers per hour. Your city would feel like a ship on a stormy ocean. Living on Crusader isn't on land, it's literally in the sky on a moving, breathing planet, and it's spectacular. Now, before we jump into humanity's far future potential, let's talk terraforming, shaping a planet to make them more habitable. In Star Citizen, worlds like Hurston and ArcCorp aren't just natural Earth-like, they've been re-engineered. Hurston's atmosphere, while toxic and industrial, is breathable in some areas with filtration systems, and the planet's surface has been modified for mining, cities, and infrastructure. ArcCorp, that's a complete overhaul. The entire planet is urbanized, terraformed to suit life and a corporate expansion. The idea that in 2955, humans are advanced enough to control atmospheres, surface climates, and large-scale planetary systems, essentially turning any world into a functioning human habitat. Now let's bring this closer to home. Mars. It's the planet in our solar system that is most often discussed for colonization and terraforming. Unlike Star Citizen's fictional planets, Mars starts off hostile. It's got a thin CO2 atmosphere, average surface temperature around 60 degrees Celsius, low gravity, no global magnetic field, and scarce liquid water. So how we might terraform Mars step by step? Well, scientists have proposed several approaches. The first one would be atmospheric thickening. This would be through releasing greenhouse gases, either by heating the polar ice caps or artificially producing gases to trap the heat and raise the surface temperature. Oxygen generation would be through large-scale electrolysis and genetically engineered microbes that produce oxygen. The other two methods would be magnetic or radiation protection, so this will be through deploying satellites or magnetic shields to protect the planet from solar wind and radiation, something that Star Citizen has had with advanced energy shielding. The last thing would be water management. Melting polar ice or importing water to create rivers, lakes, oceans would be difficult. All of this would require immense energy, advanced robotics, autonomous construction systems, life support, engineering, and decades, if not centuries, of continuous work. Basically, they kind of take Star Citizen imagines humans having by 2955. The cool part, looking at Hurston and ArcCorp, you could see that the endgame of terraforming, stable atmospheres, engineered ecosystems, controlled climates, and services reshaped for human activity. Mars in our near future is our proving ground. Every robotic rover, orbital satellite, and greenhouse experiment is a tiny step forward in understanding what Star Citizen has already depicted for our future. So in perspective, living on Hurston or ArcCorp is like seeing what Mars, after a few centuries of human engineering, would be like, and Crusader's floating habitats, that's humanity taking it even further, beyond solid ground entirely. So could humans live like this by 2955? Technologically, yes. It would need advanced materials, artificial gravity, atmospheric management systems, terraforming, life support, and energy generation would all be planetary scale challenges. But the other thing would be geologically. There will be still limitations to this. Gravity, heat, erosion, tectonics, and atmosphere, they all shape what would be possible. Hurston's heavier gravity would make life harder but sustainable. ArcCorp could exist, but only through careful planetary engineering. Crusader may be humanity's boldest dream, floating cities in the clouds. But even in the far future, humans wouldn't just be conquering planets. We'll be learning to coexist with them, adapting, building, and respecting geology, because even the best tech can't override planetary physics. And that's our journey through the Stenton system, from Hurston's scarred surface to ArcCorp's steel skyline to Crusader's drifting clouds. We've explored how real science anchors fictional worlds, how gravity shapes life, geology drives survivability, and even in the far future, nature still has its say. If you enjoyed today's episode, share it with your fellow space travelers. Tell me which Star Citizen planet or moon or system you would want me to explore next in the comments below. Also, be sure to check out my website as well. There will be a link to my Discord server. And until then, keep your quantum drives charged, your shields up, and your curiosity wide open. I'll see you out there in the Retroverse.